the use of carbon composites is very different today. We can build very sophisticated. You saw our carbon tape laying machine that builds the giant fairings, and we can build these incredibly light, very stiff fairing structures out of carbon composite material that they could not have dreamed of. I mean, the efficiency, the structural efficiency of that material is so high compared to any, metallic material you might use or anything else. So that's one. Aluminum lithium and the ability to friction stir weld aluminum lithium. Do you remember the friction stir welding that I showed you? This is a remarkable technology. It was invented decades ago, but has become very practical over just the last couple of decades. And instead of using heat to weld two pieces of metal together, it literally stirs the two pieces. There's a pin that rotates at a certain rate, and you put that pin between the two plates of metal that you want to weld together, and then you move it at a very precise speed. And instead of heating the material, it heats it a little bit because of friction, but not very much. You can literally immediately after welding with stir friction welding, you can touch the material and it's just barely warm. It literally stirs the molecules together. It's quite extraordinary.
Relatively low temperature, and I guess high temperature is what makes them that makes it a weak point.
Exactly. So with traditional welding techniques, you may have whatever the underlying strength characteristics of the material are. You end up with weak regions where you weld. Mm-hmm. And with friction stir welding, the welds are just as strong as the bulk material. So it really allows you, and so because when you're, let's say you're building a tank that you're going to pressurize, a large, liquid natural gas tank for our booster stage, for example, if you are welding that with traditional methods, you have to size those weld lands, the thickness of those pieces, with that knockdown for whatever damage you're doing with the weld, and that's going to add a lot of weight to that tank.
I mean, even just looking at the fairings, the result of that. The complex shape that it takes and like what it's supposed to do is kind of incredible because so people don't know it's on top of the rocket, it's going to fall apart. That's its task, but it has to stay strong sometimes.
Yes.
And then disappear when it needs to.
That's right.
Which is a very difficult task.
Yes. When you need something that needs to have 100% integrity until it needs to have 0% integrity, it needs to stay attached until it's ready to go away. And then when it goes away, it has to go away completely. You use explosive charges for that. And so it's a very robust way of separating structure when you need to.
Exploding.
Yeah. Little tiny bits of explosive material, and it'll sever the whole connection.
So if you want to go from 100% structural integrity to 0 as fast as possible, is explosives.
Use explosives.
The entirety of this thing is so badass. Okay, so we're back to the 2 stages. So the first stage is reusable.
Yeah. Second stage is expendable. Second stage is liquid hydrogen, liquid oxygen. So we get take advantage of the higher specific impulse. The first stage lands downrange on a landing platform in the ocean, comes back for maintenance and get ready to do the next mission.
I mean, there's a million questions, but also, is there a path towards reusability for the second stage?
There is, and we know how to do that. Right now, we're going to work on manufacturing that second stage to make it as inexpensive as possible. There's sort of 2 paths for a second stage. Make it reusable, or work really hard to make it inexpensive so you can afford to expend it. And that trade is actually not obvious which one is better.
Even in terms of cost, even like time,
even in
cost,
terms of cost. And I'm talking about cost.